So good morning to all. In today's lecture, I will discuss about the Runge Kutta fourth order method. So myself, Dr. Ankit Kumar, and I am assistant professor in the Department of Mathematics. So this is a very important methods of the numerical analysis. And in this method, we talk about how we find the numerical solution of the ODE, ordinary differential equation. Okay. So some of the introduction is given in this slide. Runge Kutta method are a family of numerical techniques used to solve ordinary differential equations with higher accuracy than basic methods like Euler's method, meaning thereby it is more accurate as compared to the Euler's method. And it is used to solve ordinary differential equations. And it is a numerical technique. So this is the key points of the in the theoretical lines. You must find the what are the key points. So these are the key points that it is a numerical technique. It is used to solve the ordinary differential equation. It is more better than the basic Euler's method. Okay. Second point is given by they were developed by the German mathematician Carl Runge and Martin Kutta in the late 19th and early 20th century. Okay. So German mathematician Carl Runge and Martin Kutta invented this type of the numerical technique. That's why it is also known as Runge Kutta method. The key idea of this method is to improve accuracy by evaluating the slope of the solution at multiple points. Okay, within each step. In each step, we evaluate the slope of the solution at multiple points rather than relying on a single slope. Because in Euler's method, we apply only single slope, but in the Runge-Kutta method, we apply we evaluate the slope at multiple points in each steps. Mean in each iteration. Okay, in each iteration, we evaluate the slope at multiple points. Okay. This points is given. Euler's method, modified Euler's method, and Runge's method are the Kutta methods of the first, second, third order respectively. Okay. So this is Euler's method, modified Euler's method, and Runge Kutta methods are the first, second, and third order respectively. Okay. So Euler's method is first order method, modified Euler's method is the second order method, and Runge Kutta method is the third order method. Among them, the fourth order Runge Kutta method is the most widely used due to its excellent balance between accuracy and computational efficiency. Okay. Among them, the fourth order Runge Kutta method is the most widely used due to its excellent balance between accuracy and computational efficiency. So, what is the basic algorithm for the Runge Kutta method? So, Runge Kutta fourth order method, which is known as fourth order method. Suppose dy by dx is equal to f of x comma y. It is an ordinary differential equation of first order. Then we evaluate yn plus and it is given by y x naught is equal to y naught. Okay, meaning thereby at point x naught the value of y is y naught, and this is the first order ordinary differential equation. Then formula is given by formula is yn plus 1 is equal to yn plus h of plus no there is no h plus 1 by 6 plus 1 by 6 k1 plus 2 k2 plus 2 k3 plus k4. Okay, so you remember this. Okay, yn plus 1 dy by dx means this is dependent variable, x is independent variable, so formula is written in dependent variable form. So yn plus 1 is equal to yn plus 1 by 6 k1 plus last k4, and in the middle slopes we write 2k2 plus 2k3, and these are the slopes. These are the slopes. So K1, how we evaluate K1? So K1 is equal to h of f of x naught comma y naught. Okay. Then K2 is h of f of x naught plus h by 2 comma y naught plus this K1 by 2. K3 is h of f of x naught plus h by 2 comma y naught plus K2 by. Okay. K3 is h of f of x naught plus h comma y naught plus K3. So this is the overall algorithm that if any differential equation dy by dx is equal to f of xy is given, okay, and one initial condition is also given at y x naught is equal to y naught, it is provided in the question, and h value is also given in the question. So you apply the formula yn plus 1 is equal to yn plus 1 by 6 k1 plus k2 k2 plus 2 k3 plus k4. So k1 is equal to h of f of x naught comma y naught. K2 is equal to h of f of x naught plus h by 2 comma y naught plus k1 by 2. K3 is equal to h of f of x naught plus h by 2 comma y naught plus k2 by 2. K3 is h of f of x naught plus h comma y naught plus k3. So this if you apply this formula, we put all the values. This is k4. We put all the values of k1, k2, k3, and k4 in equation number 1. Okay, in equation number 1. Then we evaluate the first approximation. And the second, if we evaluate y2, then here y1 plus 1 by 6 k1 k2. So this becomes accordingly. Okay, this reduces accordingly. So here what is the general formula is also provided in the question. This is the general formula. So general formula is that key. General formula is general general formula. So yn plus 1 is equal to yn plus 1 by 6 k1 plus 2 k2 plus 2 k3 plus k4. This. So what is the value of k1? K1 is h of f of xn comma yn. Here we write not xn and yn. K2 is h of f of xn plus h by 2 comma yn plus k1 by. Okay. K3 is h of f of xn plus h by 2 comma yn plus k2 by 2. And k4 is h of f of xn plus h comma yn plus k3. So this is the value. If we put these values in this formula, so this is the general formula. Suppose we want to evaluate the first iteration. The first iteration formula. First iteration. So the first iteration is given by, if we want to first iteration, then we put n is equal to 0. If we put n is equal to 0 in this equation, the formula becomes y1 is equal to y naught plus 1 by 6 k1 plus 2 k2 plus 2 k3 plus k4. Okay. And these things are reduced as k1 is equal to h of f of x naught comma y naught. K2 is h of f of x naught plus h by 2 comma y naught plus k1 by 2. And k3 is h of x naught plus h by 2 comma y naught plus k2 by 2. And k4 is h of f of x naught plus h comma y naught plus 3. Okay, so this is the first approximation. So you and if you want the second approximation, then how? Second approximation is y2. So y2 is equal to this is second iteration. So y2 is y1. Y1 means you what is the value of y1? You evaluated in the first step. So y1 is this plus 1 by 6 k1 plus 2 k2 plus 2 k3 plus k4. Okay, then k1 is h of f of in this time x naught y naught is not here x1 comma y1. Okay, because second in the second iteration we use the previous values, and this is k2. K2 is h of f of x x1 plus h by 2 comma y1 plus k1 by 2. Next k3 is h of f of x naught plus h by 2 comma y naught no x1 x1 plus h by 2 comma y1 plus k2 by 2. Okay, k4 is h of f of x1 plus h comma y1 plus k3. So this is the formula for second iteration, and similarly you evaluate third and fourth iteration. First you uh, read the question very carefully, that in which method we solve the differential equation and how many iterations we perform for the solution process. So these two things may be remember in your exam period, because this is very most important. So for the numerical technique, if you apply any of the numerical technique, first write the formula. Okay, first write the formula, and second one is how many iterations are performed. So you evaluate the given number of iterations. Okay, so it is for your time saving and for your accuracy. So this is now. So this is question is given. Okay, this question is given. In this question, h value is 0.2 is given, and dy by dx is equal to, we transform this dx by dt, so t plus x. So more for more convenience, we write this dy by dx is equal to y plus x, and y0 is 1, means that this initial condition. So all the information is given. You write the formula, yn plus 1 is equal to ym plus 1 by 6 k1 plus 2 k2 plus 2 k3 plus k4. Okay, so mm, k1 is h of f of x naught comma y naught. So h value is given 0.2. F of x naught comma y naught means f of x naught is 1, x naught is 0, y naught is 1, 0 comma 1. So f of x comma y is given y plus x. This is so f of x comma y, if this given, then f of 0 comma 1 is 1, 0.2, 0 plus 1. In place of 1, we put here 1 plus 0. So this is 1 plus 0 is 0.2. Next k2. So k2 is h of f of x naught plus h by 2 comma y naught plus k1 by 2. So 0.2 f of x naught means 0 plus h means 0.2 divided by 2 means 0.1 comma y naught is 1 plus k1 means 0.2 divided by 2 0.1. So this is 0.2. This is f of 0.1 comma 1.1. So this value is x, this value is y. So 0.2. So function is f of x is y plus x. So y plus x means 1.1 plus 0.1. So this is 0.2. This is 1.2. So this is 24. So 0.24. Okay. Now we evaluate K3. So K3 is h of f of x naught plus h by 4 comma y naught plus K2 by, so this is 0.2. So x naught means 0 plus 0.1. Y naught is 1 plus K2 means 0.24 divided by 2, so 0.12. Okay, so this is 0.2, x is 0.1 comma 1.12. So this is 0.2 x comma y. So 1.12 plus 0.1. Okay, because f of x comma y is x plus y. Okay, so if we write here 0.1 comma 1.12, then we similarly 0.1 plus 1.1. We add this. So if we add 0.2, this is 1.22. So this is 0. This is 2 to the 4, 2 to the 4, 2 and 2. Yeah, this is 0.244. So this is K3. Now we evaluate K4. So K4 h of f of x naught plus h comma y naught plus K3. So h is 0.2. F of x naught means x naught is 0 plus 0.2 comma y naught is 1 plus 0.244. So this becomes 0.2. So f of 0.2 comma 1.244. So this becomes 0.2, and this is 0.2 plus 1.244. So this becomes 0.2 and this becomes 1.444. So this becomes 8.882. 0.288. So this is the value. Now we put all the values in the formula. So formula is 1 by 6 y1 is equal to y naught. Y naught is 1 plus 1 by 6 k1. So k1 is, what is the value of k1? K1 value is 0.2. K2 value is 0.24 plus K3 value is 0.244, 0.2888. Okay, so this one. So if we solve this, we get the answer 1.2468. 1.246. So this is the overall procedure for the Runge Kutta method of first order, and this is the first iteration. First iteration. Okay. So in this question, it is written that applying Runge Kutta fourth order method to find an approximate value of x when t is equal to 0.2, given that dx by dt is equal to t plus x at x is equal to 1 and when t is equal to 0. So this is given. So if this type of the question is given in this manner, you evaluate only first iteration. Okay, first iteration, because this is a lengthy process and the time is not given in the exam properly. So you evaluate only first iteration. Okay. So you evaluate only first iteration. You find the value of K1, K2, K3, K4 and put the value in the original formula and evaluate the first iteration. Okay. And these things are play a big role, that t plus x means function. What is the function is given? What is the initial condition is given? And what is the value of h given? Because these three values are used in the formula in each step. So you must focus on these things. Okay. So if here the function is easy, it is given is very easy, then the process is very easy. Suppose it is, if it is given only x, then it is more easy. If it only given t, then it is easy. X plus t is also easy. But if it is given that xy plus x square t square, it must be little bit difficult because it is more consuming more times, and error chances is also very big. Now, this is practice problem third. What is given? This is dy by dx is equal to x plus y square is given. Okay. So dy by dx is equal to f of xy. Okay. If we compare from this, so what is the value of x comma y? So f x comma y is x plus y square is given. Okay. So these things are given. And y value is y at 0. Y at 0 is equal to 1, and we find y at 0 0.2. It is given. Apply Runge Kutta fourth order method to find an approximate value of y when x is equal to 0 0.2 is given. So, we if at y is equal to 0 is given. They ask for you evaluate at y is equal to 0 0.2. So here h value is 0. We take 0.2 value h. So if in the x-axis at x is equal to 0, y is given 1. So at x is equal to 0.2, what is the value of 0.2? This will be evaluated. So let us assume that h is equal to 0.2, means this distance is 0. If you add x, what is the value of x1? x1 is x naught plus h. So x naught plus h means 0 plus h means 0.2. So this becomes 0. So we evaluate at 0. Okay. So you also read the question very carefully, that what is the information given in the question. So now we evaluate this. So first write the formula. Yn plus 1 is equal to yn plus h of f of, we write 1 by 6 k1 plus 2 k2 plus 2 k3 plus k4. Okay. So k1 is h f of x naught plus h by 2 comma y naught plus x naught comma y naught. Okay, so k1. So 0.2 f of x naught comma y naught means f of x naught. X naught value is 0 and y naught value is 1. So this becomes 0.2. And f of x comma y is x plus y square. So 0 plus 1 square means 0.2. Now evaluate k2. K2 is h of f of x naught plus h by 2 comma y naught plus k1 by 2. So this is 0.2 f of x naught. X naught means x naught means 0 plus h by 2 means 0.1 comma y naught. Y naught means y naught means 1 plus k1 by 2 means 0.2 divided by 2 means 0.1. So this is 0.2 f of 0.1 comma 1.1. So this becomes 0.2. This becomes 0.1 plus 1.1 whole square. So this becomes 0.2. 0.1 plus this is 1.21. Okay. So this is 0.2, 1.31. So this becomes 2, 2 3 just 6, 2 1 just 2. And we place the decimal after 3 digits because here 1 digit, here 2 digits. So 0.262. Since this is the value of K2. Now we evaluate the value of K3. We must occupy some space. K2. Now K3. K3 is h of f of x naught plus h by 2, comma y naught plus K2 by 2. Okay. So h means 0.2 f of x naught. X naught is 0. X naught is x naught is 0 plus h by 2, 0.2 divided by 2, 0.1. Comma y naught. Y naught is 1 plus K2. What is the value of K2? So K2 is 0.262. So 0.262 divided by 2 means 0.131. 0.131. So this is 0.2 f of 0.1 comma 1.13. Okay. So this is 0.2. Now this is 0.1 plus 1.131 whole square. This is 0.2, 0.1. Now we evaluate 1.131. Okay. So what is the square of this? So you evaluate by the using the calculator. So 1 minute I will calculate using the calculator. So 1.131 into 1.131 is equal to plus 1.279. 1. Okay. 1.79. Okay. So this becomes 0.2. X means 0.1 plus 1.2791 whole square. So this becomes 0.2 and square plus 0.1. So this becomes 1.736. And if we multiply by 2, if we multiply by 0.2, so this becomes 0.347, 0.3472. Okay, so this is value of K3. Now we evaluate the K4. So K4 value is h of f of x naught plus h comma y naught plus K3. So 0.2 f of x naught means 0 plus h means 0.2 comma y naught 1 plus K3. K3 is 0.3472. So this becomes 0.2 and this becomes f of 0.4 comma 1.347. 0.2, 0.2 plus 1.3472 whole square. So whole square means we write here. So 1.3472 whole square plus 0.2 multiplied by 0. So overall answer is 0.4029. Okay. So if we put all the values in the formula, this formula is given. Okay. So here, if we put y1 is equal to y naught is 1 plus 1 by 6. What is the value of k1? It is k1 is 0.2 plus k plus 2 k2 k2 value is 0.262 to k3 value is 0.3472 plus k4 value is 0.4029. So if we solve this, so what is the value? Mm, you evaluate the value by the calculator. I will calculate this one. So 0.2 plus bracket 0.262 plus bracket 0.3472 plus 0.4029 divided by 6 plus, so 1.3033. So this is the answer, your final answer. Okay. So this is the Runge Kutta method. So thank you very much.